Cool.
Here we go. Alright guys, welcome back. 3D Distributed over here. We got a lot of stuff coming up this week. We got 2 different shows. And we're getting ready, prepping for the show. We thought we'd do a little video, just kind of the history of the progression of our printers that we've got going on here. So Shane, take it away. What do we got? This is the first one.
Well, Santi, I'm glad you asked. So this right here, this is the Pilot 1. This was our first printer that I built and that we designed. And basically, it's missing some parts. We had a couple of issues one time, and we needed some parts, so we kind of robbed some parts off of it for a better build.
I believe there's been a couple of times we've robbed parts off of multiple of these machines.
And that's actually why I recorded this video, because we're about to steal more parts off of this. And I thought, hey, maybe we should get a video of what the printer looks like before we steal all these parts off of it. But anyways, so we got limited time, limited resources. We have limited space. We can't really fit all of these printers everywhere, you know. So
I've had to move this table back and forth across the shop today several times to get the stuff that I needed to get to.
Exactly.
All right, so this is your first printer here.
Yeah.
Timeline. How long ago was this the main printer, and how long since then?
So this started like 4 or 5 years ago. And originally it was like a Prusa. It didn't have this frame here. It was basically this frame is built around the original printer. Okay. So what happened was it was like a Prusa. Basically you had these 2 verticals right here. This was right here. And one of the problems I had was I didn't have a good place to put the power supply. Okay. And I didn't have any good places to run the wires. So basically I had like this big hairball of wires all over the place, and it was a big pain. I wasn't really too happy with it. So what I did was, I couldn't run an enclosure. So what I did was I built this frame around the original printer. Okay. Now this was 4 or 5 years ago, so it's not as nice as the newer ones, but it's still got some pretty good ideas on here. Like I really like this Y-axis right here. So this tubing you're seeing right here, this has actually got a bunch of holes in here, and there's a lot of wire. All the motor wires and the in-stock switches and hot ends and stuff. All this wire gets run through these tubes right here, and runs up to this Aztec X3 right here.
Get under here and see that.
Yeah. Yeah. If you were able to see it here, there's a bunch of drill holes.
Yep.
So that kind of cleaned up the wire mess. Now, obviously, there's some wires hanging right here, and that's because over the last couple of years, I've stole parts or added things, and the wires didn't get ran through this tube yet. But
okay, anyways, so this is the first one.
This is the first one. It looked completely different. Also, originally, this plate right here. So the whole idea of this plate was made to have 200 millimeter by 200 millimeter heat beds on it. Okay, so basically I had 2 heat beds that were spring loaded, and there was a glass plate that went over it to basically smooth it out. So when you went and printed it across, you didn't have like a line or anything. Basically there was a piece of glass on top of it. As you can see, like right here, there's drilled and tapped holes, and basically that was for screws and springs, so you can spring load it and adjust it and do bed leveling, all that good stuff. Also, originally there was one belt in the middle, just like a Prusa. Okay. Now the problem was this bed is, this is like 1/4 inch thick, I think, maybe 5 millimeter thick aluminum right here. So it's got a lot of moving mass, right? So one of the problems I had was the belt, basically I needed 2 belts. So I had to beef it up, so I drilled and tapped these, and I ran my motor right here, and basically put some idlers and some bearings in here. Another problem I ran into was belt tensioning also. So the cool thing about this is what you can do is you can loosen these screws up right here, and pull this back until you get it tensioned properly, and then tighten it down. So tensioning the Y-axis belt was lovely. It was just so easy. You just loosen it up, pull it in, and tighten it down. Originally the Z-axis was a lot different. I went through different concepts for the Z-axis. These carriages right here, I actually stole this idea from my buddy Greg from the Open Delta project. He designed these for the Delta printer, and I took his idea and kind of modified it, where I could put a lead screw going through here. Now, there's some issues with this. It works pretty good. It's not the best setup. That's one reason why we're not using it. This was pre-Workhorse, okay? So basically with this machine, I learned a lot of lessons that brought us to the first edition of the Workhorse. But as you can see, we were trying to go with a bigger print bed. And you know, 4 or 5 years ago, this was a huge print area.
Now it's pretty tiny compared to everything we got now.
Oh yeah, yeah.
I mean, especially here in this shop, anyway.
Well, you gotta think the average print bed size was 200 by 200 millimeter, if not smaller. I mean, you'd see 600 by 600, or 4 inch by 4 inch, 8 inch by 8 inch.
Okay, so, well, this is the first one.
So this is the first one right here.
Where's our next progression going from there?
So there was a lot of issues with this, and we progressed to, let's go look at Rev 1. So this is Rev 1. This is the first prototype of the Workhorse printer. It's pretty dirty. I haven't used it in a while. The lathe throws shavings on it, and it gets a little messy.
Yeah, when we had this printer more in production, we had little walls put up here behind it and on the other side of it. 'Cause we got the mill over here and the lathe over here. So it's always, I mean, you can see some of the junk on the bed there right now. If I can find some.
And as you can see, that's why we went with the enclosure
on the other one.
Machine.
Yeah. Because we had a lot of problem here in the shop with it throwing all kind of junk and goop and metal and different crap all over the printer. So
now with the Rev 2, the Rev 2 was a pretty good machine. Now we've used the hell out of this machine, but as you can see, we used the Delrin wheels right here. All the carriages have Delrin wheels. The motor mounts right here for the X-axis are actually screwed in, attached to the rail right here. We did away with that. On the second edition, we moved it to the outside where it actually screws into the gantry plate.
As you can see right here, kind of.
Rev 3, yeah.
That's the Rev 3, yeah. But that's what you're talking about there. It's
exactly.
The difference in the motor mounts, how that motor's mounted there. This is also the first machine, though, that
the gantry moves up.
Well, that we played with these lead screws.
Oh yeah, this is the first. Yeah. Originally this was gonna be belt driven, and we kind of got wild hair and decided to go ahead and do something that nobody else was doing and go with lead screw. Everybody else is doing belt driven, and there's a lot of benefits of belt driven machines. One of the things we didn't consider when we first started with belt driven started with lead screw was we didn't really think about how long it was going to take to print something, our print speeds. So on this one, we originally had ball screw, okay, and the ball screw had a 4 millimeter lead, if I remember correctly. Now we were going for a big print bed, so let's see, this one has, if I remember correctly, this one has a 20 inch by, let's see, 20 inches on the X, 12 inches on the Y, and about 12 to 14 inches on the Z. And it was a good concept. There was some issues. If you look at this, the gantry rocks. We had some issues with that.
Yeah, it's kind of, try that again. It's kind of hard to see with the camera, especially you're kind of rocking the whole table here. But yeah, you can kind of see it moving a little bit.
Yeah, so we had a big issue with repeatability. Basically, this heavy gantry moving up and down on the wheels with the 6 wheels over here on the plates. Didn't really work too well. Like, it would go up and come down. Also, one of the dumb things that we did was we had these bad couplings. These couplings aren't for that application. That was a terrible idea. They got switched out, and somehow they got switched back on. Don't ask me how.
We probably robbed it for something else.
Yeah, exactly. Well, we're on a limited budget, so anytime we build a new machine, we can't always buy all the parts we need. So we kind of have to steal parts off the old machines for the new prototypes.
Cannibalization is a thing.
Yeah. So as you can see, the Y-axis carriage right here also has the 3 wheels. It actually worked pretty well. I had a little bit of trouble with getting everything the right size and geometry. The first few times we made it, we had problems with mechanical bind, especially when the carriage moved closer to the motor mount or the idler. In the middle, you'd have a little give in the lead screw, but as it got closer to the coupler here, or to the idler bearing, basically it would get in a slight mechanical bind and it'd skip steps. That brings us to electronics too. On this machine, we tried every freaking electronics board. A lot of them couldn't really handle the amperage, so we tried external stepper drivers. Now with the Marlin firmware, the signal it sends to the stepper drivers is such a short signal, we couldn't use CNC drivers. Now CNC drivers will work, but for a dual X-axis configuration right here, these lead screws have to be perfectly in sync. Okay, so one of the problems we ran into was the external drivers basically couldn't accept the signal properly from the electronics board, and eventually it would skip steps. And once it got in the mechanical bind from skipping steps in the X-axis, it would cause more of a mechanical bind, which would cause it to skip steps more. So that was a big issue. So that brings us to Rev 2. Let's go look at Rev 2. Alright, so this is Rev 2. I had to steal some parts off of it. Don't ask, but, you know. We don't really, a couple of these machines we don't really use that much. So the older models, you know, if we need parts, we steal the parts. But
well, like this one you pulled out of the house for this video. Well, both of these you pulled out of the house.
Yeah, these were in the back bedroom.
These two here were basically in storage, along with the rest of the parts we got over here. And these two machines were the only ones that were actually in the shop. Like we were clearing stuff out, getting ready for the show, and we brought these out, partially to rob parts off of, and partially to make this video, and all in the same theory of, or the same theme of prepping for the shows this week and weekend. But anyway,
okay, so
this is Rev 2. This is 2.0.
Okay, so this is 2.0, and we sold a few kits of these. So the cool main jump that we did with this printer was instead of these the Delta wheels for the carriages and gantry, we actually moved to linear rails. And I tell you, there's a big difference between the Delta wheels and the linear rails. If you're ever trying to decide which one you're gonna go with linear rails. These things are so cheap nowadays. It's just the way to go. So anyways, we use linear rails on the X, the Y, and the Z axis. Everything has linear rails. What we did on the X axis, we actually mounted the motor directly to the gantry plate.
Okay? Just like we were talking about, just like I showed, kind of showed you on the 3.0. But here you can see a lot better because it's not actually encased in the casing on the end. It's sticking out more.
Exactly.
But you can see the difference there. Instead of it being mounted here to this like it was in the 1.0, we got it mounted out here. So like you said, you added these, and this one we moved down. We changed the lead screw too.
Exactly.
From those other lead screws.
Exactly. That was kind of
that was a downgrade. That was an attempt to try something different and see if a cheaper product worked as well or better.
And it didn't work.
It didn't. It was a bad plan. So we went back to those other ones for the 3.0.
Now we did do some really cool stuff on this machine. So it was linear rails, the motors moved over here. With the motors mounted to the gantry plate, that allowed us a lot more travel on the X-axis. Okay, so instead of having a motor here and be limited to travel from here to the motor coupler, basically the motor you get like an extra 2 or 3 inches of travel on the same footprint. But anyways, so we tried this new lead screw. This is a lot of the lead screw you see on AliExpress or a lot of the hobbyist CNC websites. And we thought we'd try it. One of the guys said he used it and he had a good success. And I mean, there's nothing wrong with it. It's just by the end of the day, the IGES lead screw is just a little bit more, you know. So I think it's worth paying an extra $25 per printer to have the IGES lead screw. It's just a better product. One of the problems with this lead screw is it's kind of noisy. It was slower and it was noisier. This machine right here, that was one thing I hated about it. That's why you don't see too many videos of this machine, is because it was so loud that I never really got good videos of it.
Well, tell me a little bit about your coupling here that you got that mounted on the
This one right here?
axe. No, I'm sorry, right here.
Oh.
Your
Oh yeah, this is an anti-backlash nut. This wasn't the best I did. The original geometry and design was made for a IGES lead screw. So as you see, I had to make an adapter right here, and I mean it worked. It's not the best efficient design work, but you know, at the time it worked. It's supposed to be a modular system, so you can use this lead screw, you can use the IGES lead screw. If you were to take this out, the IGES lead screw and lead screw nut would pop right in here. You can't see it, but there's a slot that runs down that C carriage, and basically the shoulder of the lead screw nut would slide right in there. And there was another mounting piece that came over.
Well, that's the top. That's not a hole. That's the top of the.
No, there's actually a slot. Yeah, there's a.
That's the top of the slot. I'm saying that's not a circular hole. That's the top of the slot right there that you see there. You can kind of maybe see down in there a little bit. I don't know.
Now
no, I can't get my finger back there to show you either.
Now one of the really cool things. Along with the motors being mounted to the plate, we made these really cool Z-axis motor mounts. At the time, we were really proud of this. Now one of the problems with this.
So this is kind of the precursor.
This is the old stuff. So as you'll see on the new machine, the motor mount actually goes all the way across. It bridges, right? The reason why we did that is because we had problems. The weight from the gantry will actually flex this whole. It'll actually flex this whole extrusion right here.
You can flex it by moving that. You don't need to smack the camera to make it look like it's flexing a lot. I can see it flexing.
So the motor mount's not flexing. What you're seeing there is the actual extrusion right here, flexing right there. So that was definitely an issue, man. As the gantry would move up and down, that caused a lot of problems. You would see these motors like wiggling just a little bit, you know.
So our solution for that, we just sent out a couple of those. You want to show them one of those real quick while we're on that subject? You got one sitting over there on the desk, don't you? Here's another version of it, one of the steps, but I think there's one right over there, isn't there?
We just shipped them out.
No, it's right behind the box. The one you just ran. It's not deburred or anything, but...
Okay, this ain't polished, but...
They're not polished, they're not deburred, they're not pretty, they just came off the mill.
Yeah, this came off the mill.
But anyways, so... That's the newer version of that motor.
So this would bridge across.
Okay, come back over here with it. I'll show you real quick.
So the geometry is a little bit different, but basically it bridges across from here to here, and basically this moves in a little bit more. So this is a much better product right here. So basically that takes all the weight off of one extrusion and stops it from twisting. Now the really cool thing is what Will did. So Will came up with this really awesome concept of a 2-point bed leveling system, okay? And this is a great idea. We're still working on it. He's still perfecting it. The new machines currently don't have it because we had to make a couple of changes. But basically, there's a pivot point. Yeah, it's kind of a hairball down here, but basically there's a pivot point right here. Okay, so you have a universal joint right here, right? So basically the whole bed pivots on it. Now it's spring loaded at 2 points. So right here, you can level at this point. So you can level this direction, and then over here to the right of the machine, you go level along the y-axis. Okay.
There's your y-axis lever pulley thing, and here's your x-axis one. There is that in the middle he's talking about. You see that joint there.
So basically, it's spring loaded right here. So as you tighten this, the bed towards you will come down, and as you loosen it, it'll go up right here. So it pivots in the middle. Now this was an awesome idea. One of the issues we had with this was we lost travel on the z-axis. The bed had to be raised up to accommodate for the space that this is taking, right? Another problem we had was the plate. We actually, on the newer machines, we use a 1/2 inch. This is a 3/8 thick plate right here. So this didn't work at all. Well, I mean, it worked. Will's design actually, this is a great concept. We're just still perfecting it. But basically, we had to beef up the plate, and there's quite a few things we had to change. It has these arms right here. So anyways, so you have these leveling arms right here, and you just these knobs, and you just turn them. You level it at one point, then you come over here and you level it here. And so what we would do is we would run an indicator back and forth, and basically sweep the bed, level it from here. Then we'd go back and forth right here and level the bed from this point. So I think Will called it the 2-point leveling system. Great concept. We're just still perfecting it. One of the issues we had with that too was because you got such a big print area. When you pull big prints off of it, they cover a lot of surface, so they're really hard to get off of the bed, right? So one of the issues we had was when we pulled the print off the bed, it would throw it out of alignment slightly because these springs. There's a little bit of play in there.
It kind of killed repeatability.
Yeah, repeatability was a big issue. So we lost repeatability on the Z-axis from these motor mounts because it was twist and extrusion, and we lost repeatability from pulling parts off of the bed. So one of the big problems we had with this is to actually get a perfect first layer and a print, you would have to reprobe the bed every time, which was a big pain. Now, but the bed, because the bed was so big, and if you do a probe routine, your probe routine takes 20 minutes. So every time you want to print something, you have to reprobe the bed, and it take 20 minutes. So that's when we decided to move to the new design.
We're going over here to C 3.0 now.
All right, so this is the new design, and basically right here, the bed is fixed, okay? There's no springs, it's just mounted directly.
It's actually, you can see right there, there's one of the bolts, and it's not going to focus, so you can't see, but you can see that black spot right there in the center of your screen.
There you go.
That's some of our mounts there. Got them all the way around. Mount that bed down, and we've got all the parts around here somewhere. We haven't actually pulled the bed back out to mill it out, but we're going to make that a heated bed. We've already got everything to do it. We just have had too much work to do so far. Haven't got to it yet.
Exactly. But anyway, so this is the new design, and you know, so we now have the Z-axis motor mounts. They bridge across.
This is actually an older version, also of the ones that we just showed you. It was kind of in between the two versions we showed you. The one that's on the 2.0 and our current version. This is the prototype for our current version.
Yeah, this is the prototype of the motor mount. We changed the design for the motor mount. But we went back to the IGES lead screw.
You can see those are down here underneath. We changed kind of the configuration of everything, how we had it set up. So it's all, you know, in the same line right there. It takes up less space, makes it more effective, less mechanical binds that way.
Now one of the problems on Rev 2, the last printer we just showed you, was the motor stuck out of the gantry, right? So that was a big issue for having an enclosure for the printer. So this one, so we learned our lesson from the last design. This one, basically we designed the enclosure first and pretty much put the printer in it. Anyways, we had to take it apart because we just swapped out a bunch of stuff.
Yeah, there's you can see the holes here. There's supposed to be an enclosure piece on here too.
Yeah.
I believe that's it right there on the floor. If you can kind of see that. Right there.
Yep, that's it. But anyway, so this was designed. We fixed the Z-axis motor mount wobble problem we had from the.
And then here, once again, are those X-axis motors you're talking about, or you were talking about a second ago.
Yeah. So
they're actually hidden back in there, and you see this is the back plate. You got all our electronics inside, and there's that motor, and there's the motor on the other side over there.
Yeah, this printer is currently under construction right now. We just this is a model.
Printer is currently under update. It's been constructed and now it's going through periods.
This is more of our production model.
As we continue to.
Yeah, let's show them the new one a little bit.
But this is Workhorse, the predominant version, I guess.
Yeah, this is the current version. This one has actually been used. We've used the hell out of this printer.
This printer has been halfway across the country.
Yep.
This printer has been.
I think it's a little further than halfway. Yeah. I think we straight up drove pretty much halfway across the country.
Halfway across the country, up and down. It was only We literally drove across the country, north and south. We didn't. It's only about halfway if it was east or west.
Yeah.
But
And then we also got the Delta right here.
well, pieces of it anyway.
Yeah, pieces of it.
This is the frame.
So this was originally designed by my buddy Greg Sutherland at TXRX Labs, and basically it also used the carriage wheels. And recently we took it apart and decided to put these linear rails on here, so we're not using the black Delrin
You see, there's a couple of those on here.
carriage wheels. But anyways, so the effector, this effector was actually donated from IGES. We kind of got sponsored by them for a little while there. But anyways, so the way this works, we'll have to remachine these to actually mount directly to the linear rail carriage blocks.
Or at least an adapter plate or something.
Yeah, I'm not sure. I'm either gonna make an adapter plate, or we're gonna remachine these where it's a little bit wider and taller, so it'll actually have the hole pattern and you can just screw directly on. But anyways, so I'll get this upside down. So anyways, it's gonna get mounted right here, here. We need to put the feet back on. But anyways, so you have the motors. These are the bases right here. The motors are going to be inside of this. There's going to be a pulley that sticks out, and basically a plate that covers it. But this is a pretty cool design. We have one working at TXRX Labs.
Is it the really big one or is it the smaller one?
No, this is the smaller version. The really big one's 12 foot.
That one's not finished yet, is it?
Nah, that one's. We actually just started construction of that. It took a year and a half to design that. But that's pretty much it.
Alrighty. Is that all the printers we're gonna look at today?
Yeah, I think that's all we got today.
Okay. Well, we will be out at the trade show Wednesday, Thursday.
we had the Houston. What is it? Houston Manufacturing Show. And we got Compalooza this weekend.
And then Compalooza Friday, Saturday, and Sunday.
Yeah, we got a busy week.
That should be fun. Yeah.
Yeah.
Hope to see a bunch of you guys out there. Have a good weekend otherwise.
Bye, guys.
Peace out.